Hello, I'm Jess from Pass. Welcome to Pass Presents. Today I'm joined by Gary, TNR's Commercial and Sales Director. Welcome, Gary.
Good morning.
Gary's here to talk to us about the TNR 200ADM-P secondary current injection tester. Gary's going to be talking us through the tester, outlining its various features, capabilities and applications. We hope you find this video interesting and informative. As ever, if we do miss anything, please feel free to leave your questions in the comments. And remember to like and subscribe and share this video with anyone you think might find it helpful. So before we get into talking about the TNR 200ADM-P, please could you give us an overview of what secondary current injection testers are?
Yeah, it's very, very simple, really. Secondary injection test sets, well, all injection test sets, by the name suggesting, are current injection units. They will inject a controlled current into either a relay or a circuit to test that relay or circuit. Most skits, they operate on the basis of just one current output. And what makes this unit a little bit different, as we'll see as we go through, is we have a secondary channel, and that will give us, again, a secondary current as well as the main current. So that's where the P comes into it. And the P literally stands for phase shifting.
And what sort of professions use secondary current injection testers?
Majority of these will be used by commissioning engineers and testing technicians. So the commissioning engineers, when they commission a substation, switchgear, particularly the relays within that substation, but they may use it also to put extended current into circuits to test those circuits for joints. And obviously then and thereafter, the technicians in a company will use the unit to regularly test the relays that are in the circuits.
Right. So why are secondary current injection testers important?
Literally just to test the relays. The relays are the things that protect your expensive plant within a substation. So you're going to have a transformer. That's an expensive outlay. And if you was to overshoot that transformer or overrun that transformer and burn it out, you could be looking anywhere up to £500,000. So for the sake of a little 10 grand unit to test the relays to protect that circuit, it's a good investment. But they won't need to be told that. It's something they will do on commissioning as standard. In the same way that if you go to the other end of the scale, when you buy a new house, you wouldn't expect to move in and see these dodgy looking sockets hanging off the wall. By the same token, if you're one of the boards and you've got a contractor in to fit a substation, you'll expect that the relays to be working, to be correct, the CTs to be working and everything to be tickety-boo, as it were. And that's where this unit will come into its own.
Okay, so could you tell us about the 200ADM-P, please?
Yeah, so as I said, we've got this main output here. So the main output here has a common and then a number of taps. This is the first misnomer that people fall foul of. When they're trying to test a relay, they look at it and they're thinking, I want current. They forget that actually to get the current, they need the voltage. So, for example, they'll look and go, this is a 200 tap, and they actually want 35 amps. And when they find they're not getting 35 amps from that tap, they panic and they won't do it. And they forget actually it's the voltage that will give you the current. Yeah. Now, if we drop down a tap, you'll notice this is a 200 amp taps at 10 volts. Mm-hmm. So bottom line being, this is going to give you 2000 VA max. But to get more current, if the 10 volts is not giving me the current because the resistance of the circuit's higher, then I can drop down one tap and I can get that current because I'm now dropping down a tap in current, but I'm going up a tap in voltage and so on and so forth. So what I always say is try for the highest voltage that will give you the current that you're looking for. Yeah. If you're close to that current, maybe still drop because this has a little bit extra under the hood. We always build them with a little bit more under there than's required. So that's your AC tap. Oh, it works on a very simple basis. What we put in there is what we get out of here. So if we put a good sine wave in there, we'll get a good sine wave out of there. If we put 50 hertz in there, we'll get 50 hertz out of there. And these units are auto-sensing, so they'll give you 50, 60 hertz, 100 or 110, or 240 volts and it'll auto-select when we connect that. As well as that AC output, we also have this tap here, which is a DC output as well. So we can use this unit on places like the railway, where we'll have smaller, but we still need to test those relays for the DC protection.
So what sets the TNR 200ADM-P apart from other units on the market?
Well, as I said earlier, many of the units are single channel and they will only give you one current at the frequency, and they are effectively current injection test sets, which is why SCIT's secondary current injection test set. This one confounds because it actually breaks many of the boundaries, and it kind of breaks into other fields. So the first thing about it is, I mentioned here, we got a tap here that will give you 200 amps for 6 seconds. Many engineers out there will be thinking, hang on a minute, that's not secondary injection, that's primary. And yeah, it is. We can actually use this to operate a main circuit breaker up to 200 amps because we got 200 amps for 6 seconds. Most circuit breakers are going to operate within a second, and therefore we can operate that circuit breaker, but we can also time it. The timer, as I'll go through in a bit more in a minute, Jess, is here, but that will give you 1 millisecond resolution, which is more than enough for your average breaker tester. We have a lot of protection. So if we go in here, as I said, we've got the main taps here, but we've also, another way we can control the output is this unit, this control here. Now this we can set to 5 through up to 200 amps. It does two things. The first thing it will do is change the resolution here. So when I'm on 5 amps, I will get 1 milliamp resolution. When I'm on 200 amps, I'll get 0.1 of an amp resolution. When I'm on 5 amps, when this goes 10% above 5 amps, it will actually trip and stop. So if I've got a relay that's very, very sensitive and I shouldn't be putting too much current in, I can control or I can limit the current from here. The actual unit, when we output here, the current is turned on by hitting this on button, and then we control the current with a good old-fashioned variac. Very, very simple. So the next part that really differentiates this machine from other SCITs and makes it a little bit even more blurred, because as I mentioned, having 200 amps, is it a secondary, is it a primary? Having this auxiliary channel changes things completely. The auxiliary channel will give me a secondary output, and that secondary output will give me either voltage or current. It'll give me voltage to 300 volts or current to 10 amps. And I think I'm correct in saying there's not another SCITs that will give you 2 channels of current without an auxiliary extra device that you buy. So that's a big advantage. In that auxiliary channel, though, we can control the phase angle. So we can shift the phases between these 2 channels. We can also play with the frequency from 45 through to 100 hertz. So what that means is when we're looking at relays, it's adding a whole plethora of extra relays that we can test with this that we wouldn't with a normal run-of-the-mill secondary current injection test set. The other advantage you've got with this unit, and one of the things that I have been very proud about, is the input protection on the unit. The unit is very well protected. What that also means is I can do some very, very weird, and I have done some weird and wonderful things. One of them is I've doubled these channels up in parallel, putting a funny frequency in there with the 50 hertz in there, and then I can, so if I set that at 10 amp and I start that at 0 and bring it up, if I've got a harmonic relay that, say, trips at 20% of harmonic, I can make that up to 2 amps. And when I hit 2 amps, I will see that operate those harmonic relays. So these are some of the things that have set this unit quite apart from the others. The next thing that we've got on here, because as I said, secondary current injection test sets, or I may not have said actually, secondary current injection test sets are designed for the older electrical mechanical relays. They're big, they're clunky. You know, your 200 amps at 10 volts, that's a lot. That's 2000 VA. If you're looking at a digital relay test set, you look at 30 VA per channel. The secondary channel with this gives us the ability to also test digital relays, which is unusual in a secondary injection test set. So we've got the resolution here, but here we apparently don't seem to have very good resolution, except for the fact that I have this eye limit button. So when I turn this, if I was turning this and one was 1 amp, for example, if I hit the eye limit, that one would be 0.1 of an amp. So I then get extra resolution here and extra controllability to test those digital relays. So that is in addition to testing the older mechanical relays. Now, the advantage of this set is we can test the digital relays, but if I have a true digital relay tester, then I wouldn't be able to test the older mechanical relays that need a burden, that have a burden to them. They just won't be powerful enough. 30 VA per channel, 60 VA per channel, not going to be enough. 2000 VA, I think we can do it.
Yeah. So is it fair to say that the TNR 200 ADM-P has a vast sort of eclectic testing capability?
It has indeed. I mean, one of the things we do with our test sets is when we issue a data sheet, you'll find on the data sheets, we list out the type of relays that these units can test and the type of tests we can do. And what you'll find is if you compare this with its little brother, the 100 ADM, for example, that is a skits. It's got an output there, and that's pretty much about it. Whereas this, with the auxiliary channel here, frees it up to become a lot more than that. As I said, is it a skits? Yes. Is it a primary? Yes. Can it test digital relays? Yes. Have we got a lot of control over it? Yes. So Jess, what I would say is this is really a multi-tool when it comes to secondary current injection test sets.
So could you tell me a bit about the systems it can be used on, please?
Yeah, so the systems, effectively, as I said, what you're using this is to test infrastructure around plant that's expensive. So, for example, you install an offshore wind farm. Yeah. The actual windmills themselves, they're expensive. They will be then fed into transformers. They're expensive. So this unit, you'd be using that to test the relays that protect that infrastructure from overcurrent, undercurrent, running the wrong way. I mean, for example, some relays are designed that they'll allow current to go that way, but not that way. Okay. So if I've got a wind turbine, I want the electricity that's generated to go out from the turbine. If the wind stops, what I don't want to happen is the electricity to flow into the turbine and turn it into a big motor. Because number one, that's not making me money. That's going to cost me money. More importantly, these things are designed to go a certain way. And if they are run too much the wrong way, you'll do thousands of pounds worth of damage.
So you've run us through the main output and the auxiliary AC output. Could you please tell us a bit about this section here, please? Yeah,
that section there is very simple. There are a number of relays that require power. When they're fitted to the substation battery will give you a DC output that will feed into the relay to power the relay. And simply, this is a battery supply. So it's DC, and we have two ranges, 0 to 220 or 0 to 100, 0 to 60 and 0 to 220. And then we can control the output there. Effectively, once I set that, it's set. So if you've got a unit that requires a 24 volt supply, to meter it, I'll put it into there. I'll come back to that in a minute, but we'd meter it in there, set that, turn it on, and that then becomes our battery supply for the equipment that we're testing.
And what about the section over here, the store results?
So this is our main section here, which is where the intelligent is, and this is linked to this. So here we have the USB ports. What we have in here is two ports, one for the keyboard, and we can import information into the set, and one that comes from the set to a USB flash drive. The USB flash drive stores the data in a CSV file. We can just use good old Excel and bring the data out like that. So it makes it very usable without tying somebody into the software. To work alongside this, we have this control unit here. So this controller here is off. We have the first sign there, which is wave. Now, as I've mentioned at the beginning of this, we take the power in, and what comes in is what goes out. If you're in a area where the waveform coming in isn't that great, you're not necessarily going to know it. But what you might see is when the relay tests are carried out, the times are off. But you're thinking these relays are okay. The first thing you can do is put it into wave mode, and when you do the on and off, what that will do is store the waveform that the unit is generating. You can then look at the waveform, because all relays are designed to work on a sine wave. If it's not a sine wave, for example, if your waveform that should be like that goes more pointy and thin, but still hits the peak of the current, what you've got is not as much energy going in. So a relay that should test in 5 seconds, for example, might test in 7 seconds. So before you return all those relays to the manufacturer and then get charged for returning relays that are not faulty, you can check the waveform and make sure that that is actually okay. The next section here is auto store. And in auto store, what it will do is store the time, the date, the parameters on the screen. So there'll be 3 parameters at the bottom, 2 parameters at the top, dependent on what you've selected, and a comments field. Now, as I mentioned earlier, we're storing it in a CSV file. So in the comments field, we can even split that in even further because we've got lots and lots and lots of characters. And I mean a lot. And that means I can put in a little comment, put a comma, put another comment, and in Excel, that will put in different boxes for me. So that allows me to give you it's a lot of usability there. Next section around there is for me to put the comments in. So when I want to put a comment in, when I store the data, I hit to comment, and I literally use that keyboard to put the comments in. I've got view. Now, I mentioned earlier, we can do a lot of testing with this where we're storing the data. If I don't want to go back and go, hang on a minute, 3 tests ago, what did I get? I can put it in view. I can then control it from here, and I can view the old data on the screen on the actual unit itself, which is obviously very usable as an engineer. Set clock, I think that's pretty self-explanatory. We set the time, we set the date, and once it's set, it's stored. Now, the way that it stores the data in the machine is we've got a little penny device in there, little penny battery, and that actually holds all that memory within the unit itself. Because again, you could be forgiven for looking at this unit. It looks kind of old-fashioned. It's almost like what we've done. We've got a unit that looks like a Model T, but actually, it's a bit like the latest Ford Focus.
So how much data can it store?
How big's your memory stick? There's no limit. You're limited literally by the memory stick. We don't give massive memory sticks when we supply the units because most of the time people just want minimal data and they just want a better proof. I've been on site, I did the test, this is what I got, and maybe create an Excel spreadsheet. But if somebody wanted more data, they buy a bigger memory stick in very simple terms. The only aspect that I will mention, that sticks we supply are very, very low. They need to make sure that when they buy a memory stick, they don't use a big one, because we have had them where people snap them off and shut in the lid.
So could you tell us about this section now?
So this is our contact timing section. The contact timing section allows us to time, essentially we're timing relays normally. And what we've got is the first point there, we've got internal start. So that means when I hit that button, the timer will start. When it sees a change on either of these contacts, the timer will stop and will also cut the power to the main outputs. We have one contact. Now on one contact, that would be for a relay where even when you put the current out, the relay's not made. So you put the current out, you shut the relay. Now the minute I shut the relay, it sees a change in state here. So it starts the timer. When the relay is then operated, it will see a change of state here and stop the relay. And that's with one contact. If we've got a relay that's got a start-stop dedicated contact, we go to the 2 contacts. And in 2 contacts, generally speaking, it starts the relay here, stops the relay there. But we saw an opportunity there because there are protection devices in the world called auto reclosers. And they're designed that when, for example, you've got an overhead line and you've got a tree near it, now that tree through the summer grows. And let's say either one or 2 things happens. The tree grows and hits the cable, in which case what will happen, it'll go buzz, buzz, burn, burn, break the tree bit off. And now there's not a problem again. So the auto recloser is designed that it'll auto reclose. And if it sees the incident has gone, it's minimal interruption to power. But these auto reclosers need to be tested. And what you'll find is, especially if they haven't been operated for some time, they can be quite sluggish on the first couple. So the way that we test it is we've built in here the ability to test these auto reclosers. And if we reverse these, so this one is operated first, the unit automatically is alerted to the fact, it wants to test marked or multiple auto recloser testing. And that allows us then to do open, close, open, close, open, close. And that will actually then graph the results using the CSV file from there. We can actually take the results out, graph them out with the start, stop, and effectively we can interrogate an auto recloser. Again, this is one of the features on this unit I think is pretty unique. Okay, the next section here is current operated. And what that means is when it sees current flow through here of 10% more than the range that you're in, it will start the timer. And when it sees the current stop, it will stop the timer. And that is, again, so you could set the current output, shut the breaker, current flows out, trips the breaker, and it measures the start and stop time. We have pulse mode. Now, if we're doing, for example, a thermal relay, if you spend a lot of time setting them up, you're going to warm them up before you even start. So what we do here is we give a pulsed output, which is 200 milliseconds, and we can then set the current without warming up the relay that we're testing. We also use the pulse if I'm doing a circuit breaker test, instantaneous break on a circuit breaker, because if I'm outputting 160 amps and the breaker doesn't operate, I don't want to cause damage to the breaker by putting too much current through it for too long. So we can limit that to 200 milliseconds. And the very last position we have on here is the aux AC. And what we do is we use this as a reference for start and stopping the timer. To be fair, this is the one that I've least used myself. The others I use quite regularly, particularly the pulse, and the other one that I've used an awful lot when I worked for one of the boards, and that was for testing, as I said, the auto reclosers. You can do it with a manual tester, but you've got to be very quick at stopping the stopwatch and writing the results down. Obviously, the fact that we have that flash drive means that we can store that data nicely. And then the very last aspect we've got here is the auxiliary metering. Now, the reason we have the auxiliary metering is multi reasons. Invariably, when somebody goes to do a commission a sub, they're going to have a multimeter. But how many times have I been to the substation, opened up my thing and thought, the multimeter's on the desk? We've got a multimeter built in effectively. And what we can do is we can use it to measure. If we start down here, we've got we start at the top here. We've got DC. DC multimeter is predominantly for setting up my battery. Okay. AC has a many number of reasons we'd have it on there. If I'm using this aux channel, the auxiliary channel is blind. So we're using that to meter this. So we put it through the multimeter here and we reference it to this, and we can then use that to measure AC parameters. It'll be either volts or current in this. It'll be frequency and phase angle. We can also use it to measure power. Now, there's a relay called an impedance relay or power relay. So we can use that to look at this, look at that, and therefore that's our current, that's our voltage, for example. Ohm's law, we can then use it to measure power. We can look at it for impedance. As I said, power and impedance go hand in hand in a way. It may be that your relay's specified in terms of watts or VA, or it may be that you're testing an impedance relay, in which case we can actually show X and Y impedance and reactance in that channel there. We can use it to do CT ratio. So we can put a current from here, feed the current so we feed that current through the CT, put the return of the CT into here, and we can get a clear CT ratio. Yeah. We've then obviously got harmonics. Sorry. Yeah, we've got our harmonic channel there. So we can actually use this. I mentioned earlier we'd look at the waveform, and if we suspected that the waveform wasn't a sine wave, it means it has harmonics. Obviously, to measure that waveform, I've got to put that into here. I've got to now take that out, put it into a PC. The waveform is invariably used as proof that we had a sine wave. But when we're on site and things are not going right, we would go to harmonics, have a look at it, and look at it to the 31st harmonic and see what harmonics are there. And if the harmonic level is too high, we know that it's not a great way to be measuring a relay and timing a relay. So we need to do so with a waveform to clean that up.
So obviously accuracy is critical. How do you ensure that the secondary current injection tester remains accurate?
Well, from the factory when they're built, they're calibrated, and every single of these channels are calibrated. The important ones being the voltage and the current coming out of there is metered correctly. The voltage, the current, the frequency, and the phase angle shift between these two is metered correctly. And the next very important aspect is the timer. So they're the key critical. There are other points, but they're the key critical points for this. So when it comes to the factory, the unit is fully calibrated, and we would anticipate that most companies should be looking to recalibrate or have these checked at least once a year, preferably by a company like yourselves at Pass or one of our other authorised distributors, or indeed with ourselves. But they should be satisfying themselves that they are using a authorised company to ensure that the calibration carried out is in line with the manufacturer's recommended.
And Pass is one of those authorised companies, and you can find all calibration information on our website, www.calibrate.co.uk, where you can also get a quick quote. So commissioning engineers and maintenance engineers, their jobs are time critical. They need to maximise productivity. How does the TNR 200 ADM-P aid in that?
What we've done is we've kept things simple. Obviously, there's two ways you can approach this. You can have a unit where you program it up, you put the right wires to the right place, hit go, and it does it all automatically. And that works relatively okay for maintenance engineers. Commissioning engineers, on the other hand, when they get to a site, things may be, but they may not be correct for that site. So they may have to tinker. Yeah. And obviously, the fact that this is a manual set with so much ease of control allows them to quickly and easily either find silly little problems in commissioning or rectify silly little problems when they commission and have the site ready and commissioned on time.
So clearly working with these sorts of systems can be a bit risky. So what sort of safety features does the TNR unit have?
Well, first of all, secondary current injection is normally, as I said, very high currents, but at relatively low voltage, generally speaking. But those high currents, whilst they're not necessarily a danger to us, because 10 volts is not going to push an awful lot of current into a human being, the problem you have got is you're working with expensive equipment. So, as I said earlier, we've got a number of things here. We've got ability to limit what's going output here. The unit itself also monitors the total VA of what's going out, and if it sees an excess, it will trip out. So these things have a duty cycle. A duty cycle is so long on for so long off. Now, most engineers ignore that. They get it in the manual and it'll be clearly laid out. We know that. So what we've done is we've programmed the unit to monitor itself. And if it's over exceeded, then it will come up and say duty cycle and basically won't allow you to do anything till it's called back down again. Now, that is a saving grace for this unit. And to be fair, many current injection test sets will do the same sort of thing. But it's one way of making sure that your investment in your tested equipment is well looked after.
So there are many secondary current injection testers on the market and current injection testers on the market. Why should commissioning engineers or maintenance engineers invest in this one?
Well, Jess, you're right. There are many. I mean, if you look at TNR alone, we've probably got 5 variants of secondary current injection test sets. This I would describe as our flagship, and dare I suggest probably the flagship amongst secondary current injection test sets. The reasons being very simple. Number one, not many will give you 200 amps at 10 volts. Most of them top out around about 100 amps. Secondly, the auxiliary channel. Now, there are quite a number out there that will give you an auxiliary channel, but as I said earlier, those that do give you an auxiliary voltage with frequency, and you can change the phase shift. But what they don't give you is current, so you have to buy another little box for that, which can be expensive, but also, more importantly, it's another thing that you got to carry about when you're doing your commissioning in a substation, and they tend to be a little bit remote. The waveform is unique to TNR, and we are going to be slowly introducing that across our range to many of our other sets that are more basic. But all in all, if I was going to spend my money, I would want to get those extra features, because those extra features, instead of testing 15 different types of relay, we open it up to maybe 40 different types of relay and different types of testing. One of the things we can actually do that I hadn't even mentioned with this, for example, is we have the ability to do CT saturation tests, i.e. what we do is we input voltage into the CT and we monitor the point at which current flows, and that gives us what we call a knee point graph. And that knee point graph means we can then check the CT for its magnetism. CTs lose magnetism over a period of time. It's one of the many things about this unit. Tying that in with the CSV file here from our flash drive means that we can, not only can we get the results, but we can actually graph them. And most manufacturers can't do that.
Great. So it's pretty future-proofed then. And it's probably going to save you money down the line because you don't have to then reinvest in a load of other tools in order to test what this one can already test.
I reiterate what I said earlier. It's the multi-tool of testers.
It does come with a metal case or a Peli case, doesn't it?
Yeah, when you buy the unit, the only choice we give you, some manufacturers, as I alluded to earlier, they'll ask you, do you want 240 volts or do you want 110? And you have to pick. And if you've picked the wrong one, that means you go to a sub and go, well, can't do the testing. They'll ask you, do you want 50 hertz or 60 hertz? That's okay if you're in America or the UK. But if you travel the world doing commissioning, well, you might need a number of different sets, and make sure you take the right one with you. This one, just one does all. Okay. So, in answer to your question, Jess, the original question is metal or Peli case. We offer it in either. If we buy it in the metal case, we give you a separate case for the lead set, and that's all included. The full lead set is there. Or if you buy it in the Peli case, you have room in the Peli case to store your leads. I don't know if I should add this, but my preference has always been for the metal case. A little bit smaller, a little bit easier, and certainly people tend to seem to look after their metal case ones better than they do their Peli case ones.
So say you bought a metal case one, but then you thought, I'd quite like a Peli case. Can you fit the metal unit into it?
We can, or even PAS can, or any of our authorised distributors can. We put the unit in a metal case. If it was to be swapped to a Peli case, you have a framework that goes into the Peli case, gets fitted, and then you literally take that out with those handles by undoing it, drop it into the Peli case, and it gets screwed into position in the Peli case. It's quite a quick and simple job. Not cheap, because obviously you're swapping it around, but as I said, that's not a problem to do. And my preference would be, if you've got a Peli case and you want a metal case, putting it back the other way is just as simple.
And is there anything else you think we should know about the TNR 200 ADM-P secondary current injection tester?
Now, to be fair, I think we've actually covered everything, but I'm sure that if any of your subscribers have questions, we can, between us, answer those questions for them.
And finally, if you were to sum up the TNR 200 ADM-P secondary current injection tester in 3 words, what would they be?
In summary, I would put this as the ideal commissioning tool for an engineer to go out and be easily, manually set up, use, and get results very, very quickly.
Excellent. Thank you for speaking with us today, Gary.
It's been a pleasure. I've enjoyed it. Thank you, Jess.
I hope you found that informative. If you did, please remember to like and subscribe. As ever, if we did miss anything, please leave a note in the comments. Remember to look out for future episodes with Gary covering more of TNR's best-selling instruments. You can find all information about TNR's 200 ADM-P secondary current injection tester on our website, www.tester.co.uk.